Assalamualaikum and good morning everyone. Today we continue speed revision SPM KSSM on topic quantum physics. So this is the one new topic added to the KSSM syllabus. Maybe some of you not really familiar with the formula because a new topic. So today we try to have one slot of speed revision on this topic. Okay, what you have studied in 7.1? Okay, we studied about quantum theory of light. So under this topic, you must be able to explain the initiation of a quantum theory. Bagaimana quantum theory boleh dihasilkan. Describe quantum of energy, explain wave particle duality, explain concept of photon, and then you must be able to solve problem using the photon in energy formula. So you have this formula, E equals to HF. So E is known as photon energy. H is the Planck constant. You can check the list of formula for its value. And then F is the frequency. This one we call it photon energy. And then the power equals to NHF. Okay, where N is number of photon. In Form 4, you have studied about light, which is in form of continuous spectrum. So in this topic, quantum, it produces quantum theory of light. It states that light actually is not continuous. It travels in form of packets of energy. That's why we can count how many photons, number of photons. It's a packet of energy. Okay, it's not just travel continuously like this, continuously. So according to quantum, the photon energy is in this form, packet. So you can count how many photon, okay, travel. So this is photons, okay. So discrete form. Discrete means you can count, not continuous. Okay, 7.2, you study about explain the photoelectric effect, and then identify 4 characteristics of photoelectric effect that cannot be explained using wave theory. And then the 7.3, you study about Einstein photoelectric theory. Okay, the work function, okay, the threshold frequency, okay, the threshold wavelength. Okay, so you must be able to define what is work function. Okay, threshold frequency, and also threshold effect. So the work function W equals to HFO, Planck constant multiply threshold frequency. So this one we call it threshold frequency. Okay. And then you must be able to solve problem using Einstein equation for photoelectric effect, explain production of photoelectric current in photocell circuit application, and then describe application of photoelectric effect. Okay, let's look at some formula, important formula for this part. Okay, for 7.1, quantum theory of light, the concept of black body. What is the definition for black body? Okay, just saya hitam, black body. Means if we talk about black body, is an idealized body which can absorb all electromagnetic radiation that falls on it. And also it can emit thermal radiation depending on its temperature. Okay, so it able to absorb all range of electromagnetic radiation. Okay, so object emitting electromagnetic radiation, which is determined by its temperature. Electromagnetic radiation includes what? What we talk about electromagnetic radiation, it also includes visible light. The color or the radiation in terms of light that can be seen by our eyes but also cannot be seen by human eye, such as infrared radiation. Okay, so I think you still remember the spectrum of the visible light. Okay, in Form 4 you have studied about spectrum of electromagnetic wave. I hope you still remember. The first one you have gamma rays, and then you have X-rays, ultraviolet, then we have visible light, we have infrared, microwave, and then radio wave. So all arranged according to wavelength and frequency. So you can see from gamma to radio wave frequency decrease, the wavelength increase. Okay. So you can see for the visible light, for example, the light produced by sun is white light. Through dispersion, you can observe there are 7 colors: red, orange, yellow, green, blue, indigo, and violet. Okay, so all this we call it visible light, means our eyes can see. Yeah. For infrared, this is out of our the visual range for us to see, so infrared cannot be seen. So we talk about electromagnetic radiation produced by black body. Depends on its temperature. It can produce visible light and also non-visible light. Okay, infrared or ultraviolet. This one we cannot see. We just can observe the 7 colors: red, orange, yellow, green, blue, indigo, and violet. Okay, so you must understand the concept of black body. Okay, idea of the quantum physics theory. Okay, the graph. This is the intensity of light, or intensity of radiation. Keamatan cahaya. Okay. So according to classical physics, when temperature increase, electron vibrate with more energy and produce more light. Frequency of electrons, vibration has no limit. Light energy produced can reach unlimited values. So this axis wavelength. Okay. So relationship between wavelength and frequency is inversely proportional. So if we go from right to left, wavelength decrease means frequency increase. So frequency will increase from here to here. So the radiation produced depends on temperature. According to classical physics, it will emit radiation with a frequency that has no limit. If you look from here, this graph represents experimental result, which is done by quantum theory. So you can see when temperature is very high at this point, okay, suddenly the frequency or intensity of light decrease, okay, at highest frequency. Okay, so less light is produced here at high frequency, very high frequency. Okay, so this is produced by quantum theory, but for classical theory, yes, at high temperature it will produce high frequency of light, but no limit, means the graph keep increasing here. That's the difference between classical and quantum theory. This is classical physics. Okay, this is quantum theory. Okay, so experimental result prove that classical theory is wrong. Okay, it become like a UV catastrophe. Why? Because at high temperature here, the UV must release. Okay, the UV release, but the intensity of UV decreases. Okay, to this part. So means it against the classical theory already. That's why here we call it UV catastrophe. Okay. Experimental results are not consistent with classical physics theory. Light intensity does not continue to increase with increase of wave frequency. Okay, so because as the frequency increase, the intensity must increase, when it should be increased like this according to classical. But proved by experimental result, it will drop. Okay, you can read more about the history on the scientists that involved for classical theory and quantum theory. The basic, you must understand basic, okay, of quantum theory. Now I just go to the formula that involved for calculation. Okay, let's look at the formula. Okay, of course the basic formula you must know for light. From the formula V equals to F lambda. This one we study in Form 4. Because of the, for example, the visible light or electromagnetic wave spectrum all travel with speed of light. Thus V equals to C, speed of light. Okay, so you will get C equals to F lambda. Okay, so from here you get F equals to C over lambda. From the photon energy, E equals to HF. You can substitute F to this formula, you will get Hc over lambda. And then from the formula of power, NHF, thus you get the formula equals to NHc over lambda. Okay. So you must understand what is photons. Whenever I mention about photons, this one actually is light energy. That travels or transferred in energy quanta. Okay, discrete energy, discrete energy. Okay, and then about wave particle duality, that shows that wave properties undergo diffraction and interference. For particle properties, possess kinetic energy and momentum. Louis de Broglie hypothesis, all particles can exhibit wave characteristics. According to Louis de Broglie, so you have the de Broglie wavelength, okay, lambda equals to h over p, where p is the momentum equals to product of mass and velocity. Okay, when electron can travel at certain speed, okay, it has momentum, same as a photon. Okay, electron of course is a particle, but how can a photon also shows the properties of particle? Because it also possesses momentum and kinetic energy. That one shows that photon have a particle wave duality. Okay, same as electron. Electron also can be diffracted, experience experience diffraction interference. So electron also experience wave properties. That's the one we call it wave particle duality. So from here we get lambda equals to h over mv. From the formula of kinetic energy, K equals to half mv squared. So we can substitute V into the formula here V. So from here we get V squared equals to 2K over M. Okay, thus equals to two K over M. So I will substitute into this formula. So I get lambda equals to H over M square root of 2K over M. This one we can simplify. Thus we get de Broglie wavelength equals to H over square root of 2nk. Okay, so this is the de Broglie wavelength. The Planck constant, you can check the value. H equals to 6.63 times 10 to the power of negative 34 joule-second. Okay, that one is Planck constant. Can be determined throughout the experiment. Okay. For the de Broglie wavelength, it's just valid for a very small mass. Very small mass. If not, for larger mass, the wavelength cannot be detected. As you can see the relationship here. Okay. So if the mass is large, the wavelength is too short, thus cannot be detected. That's why for de Broglie wavelength, the particle wave duality just valid for a very small mass, like electrons. Okay. That's also caused the invention of electron microscope. Very high power of microscope. Okay, and then we discuss about photoelectric effect. So from here you must know what is threshold frequency. Okay. FO. So the threshold frequency, minimum frequency of light. Okay. Minimum frequency of light. Needed for a metal to emit electrons. Okay, so the photons that, for example, photons that hit the surface of metal, if the threshold frequency of the photon that reach the surface of metal, okay, is equals to minimum frequency of light required, or we call it threshold frequency, thus the metal surface will emit electron. The emission of electron from the surface of metal, we call it photoelectric effect. Okay. The kinetic energy of the photoelectron does not depend on intensity of light. Okay. Say we have the graph. Intensity against voltage. You can see the value of voltage here. Okay. So at this point, you can see intensity 0. Means if the voltage is less than this value, we call it activation voltage. Okay. Current. So there's no current produced, means no photoelectric effect occur. Once the photoelectric effect occurs, start from here, you can see the current start to increase. Means electrons start to be emitted. This one we refer to the photocell circuit, photocell circuit. So the value of voltage required here, we call it activation voltage. Let's say we have another graph. Activation voltage against 1 over lambda. Okay, so this is the threshold frequency, or this one is equal to, I can say, because the level here is 1 over lambda, so here it becomes 1 over lambda naught. Lambda naught is threshold wavelength. Threshold wavelength. Okay. If you determine the gradient of the graph, yeah, okay, so you will get the gradient of the graph M equals to HC divided by E. Okay, the formula for Einstein, photoelectric theory. So we have this formula: P, photon energy, equals to work function plus K maximum. Or we can write as HF equals to W plus half mv squared maximum. Okay, so W is threshold frequency equals to HFO. Thus we get half mv square maximum equals to HF minus HFO. So we can determine the maximum kinetic energy of the electrons emitted through photoelectric effect. So we have a graph. Kmax against frequency. So this is the threshold frequency. So to determine the threshold frequency, FO from this graph is the x-intercept. If you want to determine the work function, if you have value below here, you can extend the line. So this is the value of threshold frequency actually here. Sorry, the threshold, the work function, work function. W equals to HFO. Okay. Or you can just calculate W equals to HFO. So the work function actually the y-intercept, the work function, negative y-intercept below here. Okay, then the rest of it is about application. You can go and read more about the application of threshold frequency and also the photoelectric effect. Photoelectric effect. Okay, let's look at some question on this one. Okay, question number 1. Table 1 below shows part of electromagnetic wave spectrum: microwave, infrared, ultraviolet, X-rays, gamma rays. Position of the visible light is where? Where is the visible light? Okay, you can see it is here, visible light. So it is between ultraviolet and infrared. Okay, between infrared and ultraviolet. So answer is B, boy. Okay, question number 2. Which of following is a particle of electromagnetic radiation without mass? No mass. Photon. Okay, light. Yeah? Which of following is also known as classical theory? Classical physics. Scientists not contribute to quantum theory. This is classical theory. Okay, number 5. A beam of monochromatic light is incident on metal A causes production of photoelectrons. The rate of photoelectron produced will be double if rate of photoelectrons produced will be double if intensity of light is double. Means number of electrons emitted per second. Rate of photoelectron produced, it depends on intensity. But kinetic energy does not depend on intensity. Number 6. Which of the following are not referred to application of photoelectric effect? Okay, to count vehicle passing a road, just like detector. To operate house electric bell, electric concept. Operate burglar alarm, this one can use the photoelectric effect. To count item running on conveyor belt, also can. Okay, so this is not application of photoelectric. Number 7, determine the energy released by a quantum of radio wave with frequency 103.3 megahertz. Okay, from a radio station. E HF. Okay, the Planck constant 6.63 10 to the power of negative 54. The frequency 103.3 10 power 6 mega. Okay, you calculate for this one, you will get the answer is this one should be the power. This is not so negative 42. Okay. Number 7, you can calculate, you should get the answer 6.84 10 to the power negative 26 joule. Number 8, which of following is the evidence of existence of discrete energy? Line spectrum from mercury vapor lamp and excite electrons. Okay, will produce radiation in form of line spectrum. Okay, so each of the line will have its unique lambda and frequency. So we call it line spectrum. When you discuss about white light dispersed through a prism, you will get spectrum of continuous light. Okay, red, orange, yellow, green, blue, indigo, and violet. Okay, that one is continuous spectrum. When we discuss about radiation emits from the excite electrons, it will produce line spectrum. So the line spectrum shows the existence of discrete energy. Okay. Okay, let's look at one question for paper 2. Diagram shows a laser pointer which is usually used together with presenter. A wavelength of light given. The power is 1 milliwatt. State one characteristic of photon. Photon is a light energy that radiates. For example, black body emits radiation. So that one in form of photons. So in photons show properties of light. For example, no mass, no charge or neutral. So you can just write any one of the characteristic. Okay. Okay, for example, no charge. Photon has momentum and energy. And energy or kinetic energy. Okay. Travel at speed of light. Okay. Value 3 times 10 power 8 meter second to the power negative 1. Is it possible to notice the individual photon in laser with unaided eyes? Explain your answer. Can we observe the packets of energy? We cannot observe that. We just can observe light that travel like continuous light. Okay, we observe it like continuous light. So when we choose unaided eyes, we just can observe the photons act as a wave. Okay, overall as a wave, not a particle. Okay, we cannot observe that. Okay, part C, calculate energy of photon of a laser light. Okay, same formula, Michelle. Okay, given is lambda, lambda. Look at the question again. The wavelength is given, the power is given. One milliwatt, 600. Okay, we use this formula, C equals to 3 times 10 power 8. Okay, so we get the value is 2.97. Okay, so I think for the quantum topic or quantum physics topic, I will stop here. So maybe we can discuss more in the next lesson on some question, for example, essay question. Okay, so thank you for watching. Bye.